Now that we've looked a little bit about logic, its fundamental importance, and a very simple mechanism of logic, the syllogism, let's take a look at how it can be applied in higher levels of study in the Quadrivium. As we've established, logic is the basis for certain and demonstrable reasoning. That's why it was so heavily emphasized in classical education. And as we progress from the trivium to the quadrivium, we see these logical principles applied in mathematics and natural philosophy. We're going to look at one example from Euclid. Euclid, the chief author of the classical textbook on quadrivium geometry, the Elements, demonstrates the principles and operations of logic in two-dimensional geometry. These studies are really nothing more than logic studied and shown under the aspect of quantifiable space. That's all Euclidean geometry is. It's taking first principles and using them to demonstrate complex operations in provable ways. So we'll look at Euclid's first proposition from Book 1, which answers the question how to draw an equilateral triangle, or a triangle where all three sides are equal, and be able to demonstrate logically and certainly that they are all equal. To solve this, he begins with a given line, the line from A to B. That is our distance. Now, if we can establish as a logical premise that if you were to draw a circle with the center point A, then every point around that circle would be the same distance as line A to B. If you took B and you dragged it all the way around A, keeping the distance the same, you would draw that very circle. So we create that circle with center point A. Now we can create a mirror image circle, but this time the center point is B. But the distance of the radius has not changed. It's the same radius from A to B. So now we can take A and drag it all the way around B, keeping the same distance, and we have an equal circle. They have the same radius. Next, we overlap the circles. And we find that when they overlap, they meet at a certain point, marked C. Now, since C is a point that falls on the circumference of the first circle and the second circle, we can show logically that it's the same distance from each center. The line from A to B is equal to the line from A to C, because C is on the circumference of that circle, and that's equal to the line C to B, because the point C is also on the circumference of that circle with B at the center. So logically, visually, we see that all three sides are equal. And that's a very simple example of how you can use these logical propositions, these premises, to build mathematical proofs.